Using the method of your choice, evaluate each of the following. Want to evaluate the integral of x squared, natural log of x, dx. Since we are using the method of our choice, when you have got a product of two functions, you want to find the integral. The easiest one you can use is the tabular method. I'm going to have sines, derivatives, integrals. You can also use by parts, it's also simple. Now, natural log should never be put under the integral, never. So I'm going to put natural log go here, okay, under the derivative, and then I'll put x squared here. So if I find the derivative of natural log of x, whatsoever is here, I'll just differentiate it. That will give me 1. And then whatsoever I differentiated, that comes in the denominator. To integrate x squared, I'll add the 1, it becomes x to the power 3, and then divide by the same 3. And then I'll put a positive here, I'll put a negative here. If I continue differentiating 1 over x, the power will continue increasing. If I continue integrating x cubed over 3, the power also continue increasing. So I'm supposed to just end here. So I'm going to say the integral of x squared natural log of dx is going to be equal to, I'm going to multiply this together with the sign. So positive times natural log of x times x cubed over 3. That is going to be x cubed over 3 natural log of x. Now we don't have another diagonal. Okay, like we can't multiply in another diagonal because we don't have anything here. So in this case, we're going to multiply in this way. But when you multiply horizontally, that will be negative 1 over x because of this negative times x cubed over 3. 1x will cancel with 1x here. You just remain with x squared over 3. Every time you multiply in that way, you're supposed to add the integral. So that will be x squared over 3. Now every time you've got integral, you need to add the dx. Is this okay?
Yes.
Okay, and then from here we're going to have x cubed over 3 natural log of x minus, I'm going to bring this 3 outside, that will be 1 over 3, remember it's in the denominator, then integral of x squared dx. So this is going to be x cubed over 3 natural log of x minus 1 over 3. Now the x squared, the integral, just add the 1, that becomes x power 3. The same 3 divide. Since this was an indefinite integral, it didn't have limits, I'm going to add the constant c. So all I'm going to do, this is going to be x cubed over 3 natural log of x minus the, these two denominators can multiply, that will give us 27, and then plus c. If I want, I can even factorize out x cubed over 3 because it's common. So for the first one, what we're going to remain with is the natural log of x. For the second one, what to remain with is just 1 over 3, okay, plus a constant c. We can also leave it like that or like this, whatsoever that we want. Is it cool?
Yes, it is.
Alright, so the next one, want to evaluate the integral of x squared over square root of x cubed plus 2. Now, if you see something in this form, you are going to look at first the one which has got a higher power. Okay, you look at the one which has got a higher power because you know, like you can't break this question into partial fractions. So look at the one which has got a higher power, that is power 3. So if you look at the one which has a higher power, if the one which is on the other side, like on top, okay, the one which is on top has got, is just alone like x squared, then good. If there was another thing there, then that would be another case. But whenever it is just alone, you can use u substitution. So I'm going to say let u be equal to the same thing that has got a higher power, x cubed plus 2. And then we are going to differentiate. So du is going to be, if we differentiate x cubed, that is going to be 3x squared. If we differentiate 2, that will be 0. So every time you differentiate, don't forget to add the dx. So my aim is to make dx subject to the formula. That is going to be du divided by 3x squared. Just divide both sides by 3x squared. Then we are going to say the integral becomes x squared divided by square root. But where there was x cubed plus 2, I'm going to put u because that's what we had said here. Then where there is dx, we know dx is du over 3x squared. So I can see this x squared will cancel with the x squared. So I'm going to remain with the integral of, on top we just remain with 1, down we're going to remain with square root of u, which I can also write as u to the power 1 over 2. Okay, we also have this 3, so this 3 I can even put it in front here, and then du. So this is going to be, now take this 1 over 3 outside the integral since it's a constant. Then remain with integral. There u, I'll take it on top, becomes u to the power negative half. And then du. So I'll just add the 1 to the power. That will be 1 over 3 u negative half plus 1. That will be positive half. The same positive half will also bring it in the denominator. Then just add the constant c. So we have integrated. Okay. Now when you have got u divided by 1 over 2, we can also say this is u divided by 1 over 2 becomes u times 2 over 1. So u times 2, that will just be a 2. So basically this is going to become 1 over 3. Okay, and then we're going to have 2 u to the power 1 over 2, and then plus a constant c, which we can also write 2 times 1 on top of that will be 2 over 3. Then where there is u, we can put now x cubed plus 2. Remember it was to the power half, and power half means square root, and then plus a constant c. So that is how you're able to integrate. Is it okay?
Yes, of course.
Okay, and the last one there, you want to evaluate the integral of x squared e to the power negative 2x dx. You can also use differentiation by parts when you see a product, like you can use by parts. It's more like the product rule for for differentiation. Okay, so by parts is an integration method which is similar to the product rule when you are differentiating. So whenever you see a product, think of by parts. At times it can also be used substitution. Now by parts, the simplest way of doing by parts is using the tabular method. So I'm going to put sine, derivative, integral. Now if you don't have a natural log, the best thing that you put under derivative is something that you can differentiate to get a 0 at the end. Which one do you think we are going to differentiate to get a 0? X squared or e to the power negative 2x?
I think X
Uh,
prepared to
okay, x squared is going to be here. So I'm going to differentiate. If you differentiate x squared, what do you get?
2x.
Okay, and then if you differentiate 2x, you get what?
2.
And then if you differentiate 2, you get what?
A zero.
Okay, so we have reached at a 0. And then you are going to put e to the power negative 2x. Now we are integrating out. So if you integrate e to the power negative 2x, what are you going to get? What do you get?
I think you get the same one.
So what you do is you differentiate the power. If you're integrating anything that has got a base e, differentiate the power. So if you differentiate negative 2x, what are you going to get?
Negative two.
Negative 2. Okay, so this is going to be e to the power negative 2. But divide when you're integrating, okay? You're going to divide by that answer that you have gotten after differentiating. So divided by negative 2. But the negative, I'm just going to attach it here. Okay, so if you are differentiating the derivative of e to the power negative 2x, this is going to be differentiate the power, that will be negative 2, and then you multiply by the function itself. So we're going to get the e to the power negative 2 multiplied by the answer that you got after what differentiating. But if you are integrating e to the power negative 2, okay, e to the power negative 2, you differentiate the power, but instead of multiplying, you are going to divide. You are going to write the e to the power negative 2, but divide by the negative 2. So that's the difference when you are integrating and differentiating logs. And then again, when we reach here, I'm going to get this one and differentiate the power. That will still give us a what? A negative 2. So still divide by a negative 2. That is going to be e to the power positive 2x divided by, remember you have divided by negative 2, so that negative that is coming from negative 2 and this negative, they'll cancel themselves, it will just become positive. But you already have a 2 down and you are divided by another 2, so those two 2's will multiply, you're going to get a 4. Is that clear?
No, I'm a bit lost. I don't know if it's the spirit of stand still.
The what?
It just appeared now.
Okay, so what we are saying is we want to integrate negative e to the power 2x divided by 2. So we said differentiate the power, which is negative 2x, we are going to get negative 2. So we're going to write negative e to the power negative 2x over 2. You write this thing the way it is, okay, the way of this. And then now divide by the same answer that you have gotten after differentiating. That's a negative 2. So this negative and this negative cancels. Then 2 times 2, that gives us a 4. That's the one you're able to see here. Is that okay? Is it clear now? All right. And then again, because we want to reach at the same level, I've got this line, you've got this line, you've got this line. So I've got where there is a 0. It needs to integrate. So I'm also going to integrate the integral of e to the power 2x over 4. Okay. Still differentiate the power negative 2. So I'm going to write the e to the power negative 2x over 4. And then the same negative 2 which is on top, I'm going to divide by it. So that will still give us e to the power negative 2x over 4 times negative 2, that will give us a negative 8. But the negative, I'll just put it on top. So this will be negative e to the power negative 2x. I didn't even put a negative here. And then divided by 8. So this is what we're going to do. So when we reach at this level, well and good. So I'm now going to put the
So
sign.
the whole
Yes.
wait, sorry. So the whole essence is to make sure that as you are integrating, it should also reach at the same level as the one that you differentiated, which gave you to zero.
Yes, that's it.
Right.
But if you've seen the one which you are differentiating will never give you a zero, just end at the second step. So just differentiate once, just like we did for this first one. Because we knew that it will never give us a zero, so we only differentiated once. So we'll now start putting
Yeah.
signs, starting with a positive, negative, positive, and then negative. So when you are multiplying, you are going to multiplying diagonals. So you multiply like this, you multiply like this, you multiply like this. Okay? But if this was not a zero, you should have also multiplied in the horizontal like this. But remember, every time you multiply in the horizontal, you need to put integral. Now, if I multiply in the horizontal, like it will give me zero, like it will give me zero. And the integral of zero, what are we going to get? It's still zero. So that is why if there is a zero here, we don't integrate. We don't multiply in the horizontal. Okay, we just multiply in the diagonal. That means that the question we've been given the integral of x squared e to the power negative 2x dx is going to be, we'll start x squared times, so you multiply this, x squared times what is down there, that will be negative x squared over 2, and then we have got e to the power negative 2x, and then we multiply negative times 2x times what's down there. Okay, that is going to give us, that will be a negative, right? That will be a negative 2x over 4, and then e to the power negative 2x. And then we get is positive times 2 times what is down there. That is going to be negative 2 e to the power negative 2x over 8. We can also reduce this to be giving us negative x squared e to the power negative 2x over 2. Then negative a 2 can cancel with something there, that will give us negative x e to the power negative 2x over 2. And then negative, something can cancel with there, we're going to remain with a 4, so that will be e to the power negative 2x over 4. Then just add the constant c. Direct, you've integrated.